Okay, so um, imagine like those tiny little sandcastle fortresses that kids make at the beach,
Right.
and they're trying to keep the water out, right? They build these little moats and walls.
Yeah, yeah.
It's kind of like what we're talking about today, but on a microscopic level.
Absolutely. We're diving into the world of WVTR testing. It's all about how well materials can act as a barrier against, well, you guessed it, moisture.
Moisture, the silent invader, right?
Yeah.
Sneaking into our food, our electronics, anything it can get its watery little molecules on.
Exactly. And that's why WVTR testing is so crucial, especially for companies developing new materials or products where moisture is a concern.
So let's break it down. WVTR stands for moisture vapor transmission rate. What exactly is that measuring?
So it's basically telling you how much moisture can pass through a material over a specific time.
Okay.
It's kind of like a permeability scorecard. The
Yeah.
lower the WVTR, the better that material is at keeping moisture out, at being a barrier.
Got it. Got it. So this case study that we have, it focuses on a company that's, well, they're trying to figure out how good their new polymer is at this whole moisture blocking thing.
Yeah, and they hit a few snags along the way.
Snacks, huh?
Yeah, like with any testing process, there are a lot of factors that can influence the accuracy of the results. And one of the first challenges they faced was figuring out sample preparation.
Ah, so getting the material ready for its big test.
Exactly. You got to prep it just right. The size of the sample, how thick it is, even the conditions it's stored in before testing, it all matters.
Because if you don't, you're basically testing something totally different than what you're actually, planning to use, right?
Right. You wouldn't want to judge a whole cake based on just a tiny crumb.
Makes sense. Makes sense. Now, I see here they also had to pick the right WVTR method, which sounds like, I don't know, choosing the right tool for the job.
It is. It is. And you wouldn't use a hammer to screw in a light bulb.
Yeah.
So, in WVTR testing, you've got a couple of main methods. There are electrolytic cells, and then there are ceramic dew point sensors.
Okay, and what's the difference there? Like when would you use one versus the other?
Good question. So, electrolytic cells, those are really good for when you're dealing with really low moisture permeation rates, like super tiny amounts of moisture sneaking through.
Okay.
But when you're expecting a lot of moisture to pass through, then the ceramic sensors, those are your go-to.
So our company, they basically had to figure out which method was uh the right fit for their polymer, right?
Precisely. Like imagine you're trying to see something really tiny. Sometimes you need a microscope, other times a magnifying glass will do.
Perfect analogy. But wait, there's more, right?
Yeah.
There's the whole testing equipment itself, too,
Oh yeah, that's a big one.
making sure everything fits and works properly.
Absolutely. So those samples, they got to fit properly into these testing chambers, which have specific dimensions, like
Right.
standardized. And if you try to cram in a sample that's too big or too thick,
You can have a bad time.
you're going to skew the results. It's like trying to fit a square peg in a round hole. It's just not going to work.
It's all starting to make sense now. So this is where I'm guessing Infinita Lab stepped in, right?
You got
They're kind of like the expert tailor, making sure everything fits perfectly before the big show.
exactly. So they guided the company through that whole sample prep process, making sure those samples were the right size, 4 by 4 inches, and less than 2 millimeters thick.
Those are some specific measurements.
They are. And Infinita Labs also helped them pick the right WVTR method, based on the expected permeation rates and all that.
Okay. Okay. It's all coming together.
Yeah.
Now, there's one thing I'm a little fuzzy on, this whole carrier plate thing. What's that all about?
Oh, yeah. So sometimes the material you're testing, it might be too delicate or too flimsy to just put directly into the testing chamber.
I see.
So a carrier plate, that's basically like a sturdy little support system. It keeps the sample in place and makes sure the test runs smoothly without messing anything up.
So it's like a tiny little stage for the sample to perform on.
Exactly. Gotta make sure the star of the show is well supported, right?
Absolutely. It's really amazing how many different factors can influence these tests, you know? It's like a whole science in itself.
It is. It is. And it's all about getting accurate data so that you can make informed decisions about materials.
And Infinita Labs, they really seem to know their stuff, helping this company navigate all these complexities.
Yeah, they do. And, it's not just about numbers on a report, right? Getting this stuff right has real world consequences. Think about it like a moisture sensitive medication that goes bad because the packaging wasn't properly tested.
Oh, wow.
Or maybe a sensor in your phone that malfunctions because moisture got in.
Okay. Yeah, that's not good.
Not good at all. It highlights how important this kind of testing really is.
It really makes you appreciate all those things we just take for